Assalamualaikum and hi everyone. Today I would like to present air conditioning and refrigerant principle. The title is oil and gas platform and counter floor heat exchanger. The record number is DJU 31012. Lecturer name is Puan Mahani binti Muhammad Zamri. My name is Saifuddin Muhammad bin Muhammad Zamani and my metric numbers is 01DPU23F1076. This is a content. What is in the content is introduction, type heat exchanger, application, process, advantage and disadvantage, calculation and conclusion.
Assalamualaikum and good morning. My name is Lutfi Al-Azim Muhammad Fauzan and my metric number is 01TPU23F1053. Now I will talk about introduction of a heat exchanger. Heat exchanger is a component in an heating, ventilation, air conditioning HVAC system that transfers thermal energy from one medium to another. Two main types of heat exchanger are evaporator coils and condenser coil, both of which assist in the heating and cooling of home and building.
Assalamualaikum and good morning. My name is Muhammad Husni Daniel bin Zulkifli and my matrix number is 01DPU23F1058. Now I would like to talk about what is the counterflow heat exchanger. A counterflow heat exchanger is a device that transfers heat between two fluids by having them flow in opposite direction. The design is more efficient than other type of heat exchanger because it maximizes the temperature gradient between the fluid.
Next, this is a type of heat exchanger used in the oil and gas platform. The first one is shell and tube exchanger. Second, evaporator and boiler. Third, there is a double pipe thermal exchanger, and the last one is plate heat exchanger.
The advantages and disadvantages of counterflow heat exchanger. The advantages is more uniform temperature difference between the two fluids minimize the thermal stresses throughout the exchanger. Second, outlet temperature of the cool fluid can approach the highest temperature of the hot fluid. Then the disadvantages of the counterflow heat exchanger is less uniform temperature distribution. The temperature difference between the two fluids may not be as uniform, which can increase thermal stresses throughout the exchanger. Lower efficiency, the outlet temperature of the cool fluid may not reach the highest temperature of the hot fluid, potentially reducing the efficiency of the heat exchanger process.
This is a process of heat exchanger. Heat exchanger function by bringing in cool fluid into close contact with a hot industrial process or piece of equipment. This allows for an exchanger of the heat between the two medium by using the principle of thermal heat conduction. In the some case, the media coolant and heat process are in direct contact, but for the majority of heat exchanger types, there is usually a separating barrier between them. And this is a example picture for counterflow heat exchanger and counterflow diagram.
Other than that, application. The oil and gas industry commonly use pressure vessel to store, transport and process fluid and gas under high pressure and temperature. These vessels are robustly designed to endure high pressure and can contain the hazard material used in the industry. A storage tank is example of a pressure vessel used in the oil and gas industry for storing crude oil, refined petroleum product and other liquid. They are capable of handling high pressure and temperature and range in size from small container to massive storage tank that can store millions of gallons of fluid.
This is a part calculation. The part calculation it have example equation. The example equation is we have a counter flow heat exchanger on an oil and gas platform where the hot fluid is crude oil and the crude fluid is cooling water. The goal is to calculate the heat transfer rate Q. Given hot fluid inlet temperature TH1 equals to 130 degrees Celsius and outlet temperature TH2 equals to 90 degrees Celsius. For cool fluid is inlet temperature TC1 equals to 25 degrees Celsius and outlet temperature TC2 equals to 35 degrees Celsius. Overall, heat transfer coefficient U equals to 500 watt cube meter Kelvin and heat exchanger surface area A equals to 150 cube meter. This is a part solution for example equation. The first, calculate the LMTD. You can use the LMTD formula. LMTD equals to delta T. Delta T equals to 120 minus 25 minus 90 minus 35 over launch 120 minus 25 over 90 minus 25. Next, delta T equals to 95 minus 55 over launch 95 over 55. And the final calculation is delta T equals to 40 minus launch 1.727. Next, calculate the heat transfer rate equals to Q. You can use a heat transfer rate Q formula. This is a Q equals to UA delta T. Q equals to 500 watt per cube meter Kelvin multi 115 cube meter multi 73.0 Kelvin. Next, 500 multi 150 multi 73.0, and the last calculation is Q equals to 5,475,000 watt, and you can simplify the equals to 5.475 m watt. 5.475 is a heat transfer rate Q in the counterflow heat exchanger.
The last part is calculation of pressure vessel and oil and gas platform. First one is calculation for pressure vessel. Pressure vessel are essential containers that store liquid and gases at high or low pressure and are critical to modern industry. They are used in a variety of applications such as oil and gas, aircraft and hydraulic system. Second conclusion is oil and gas platform. Role in the global energy landscape. Offshore oil and gas production is a vital part of the global energy landscape, but it also presents challenges that must be managed through innovation, regulation and sustainable practices.